This is the DB32 portable digital bending machine. It's a rotary draw type bender with digital LCD control for fast, precise, and repeatable results. It's fully compatible with European Union CE, CB, and EMC standards. It can cold bend coated and uncoated copper, steel, and stainless steel tubing from 5/8 to 1.5 inches outside diameter, as well as some sizes of pipe and conduit. It can quickly bend to any selected angle up to 190 degrees at 3.5 RPM. For plumbing, it can eliminate the need for soldered, press fit, or threaded elbows, saving time, effort, and the possibility of leaks. You can create a series of bends in a single tube to keep joints at a minimum. Just use the bending chart in the instruction manual to calculate the leg lengths. For fabrication work, it's a versatile bender with precisely controllable results. It has a 1700 watt high torque motor with heavy duty reduction gear train for even the most challenging bending jobs. Controls include the trigger switch, direction lever, and degree selector thumb wheel. The collapsible tripod with Velcro strap is standard equipment. No vise is needed. It's quick and easy to set up. We offer a selection of former bending shoe sets in a variety of sizes with outside diameter sizes of 5/8, 3/4, 7/8, 1 inch, 1 1/8, 1 1/4, 1 3/8, and 1 1/2, which bend in a centerline radius 4 times the tube diameter. The formers allow cold bending with minimal distortion. As a portable bender, it's unique in the industry in having microprocessor-controlled bending and an LCD display. This allows you to precisely preset the desired bending angle simply by turning the degree selector thumb wheel. Much faster and easier than competitors' mechanical logic systems. Springback is an ever-present factor in bending operations. Different materials, wall thicknesses, and the angle of bend will all affect springback. It has programmed in springback compensation, but this will sometimes need to be fine-tuned. The good news is it has never been easier to compensate for springback than with this machine. The digital control allows you to make precise incremental adjustments in order to get the exact desired angle. So for example, you need 92 to get a resulting 90 degrees. Once found, the correction factor will be consistent for a given material and bend angle, saving you time, frustration, and wasted material. The blow case holds the machine, shoe pivot bolt, and 5/8 through 1 1/4 inch former shoe sets. Truly a versatile bender which saves time and gives top quality results. When the machine is first plugged in, 1-1 should be displayed, which indicates that it's at the 0 degree starting position. Select reverse by turning the direction lever to R, then press the trigger and 0 will be briefly displayed, followed by the last bending angle setting. If when you plug it in, it isn't at the 0 degree starting position, 0 will be displayed. Select reverse, then press and hold the trigger until the spindle returns back to the 0 degree starting position. Select the correct size bending former and shoe. Add some light oil to the tube. Insert the tube into the bending former with at least 10 millimeters projecting beyond the driver hook. Mount the shoe and shoe pivot bolt. View the LCD screen and set to the desired angle by turning the degree selector thumb wheel. We'll adjust to 90 degrees. Set the direction lever to forward by pushing the lever to the right F position. Press the trigger switch and hold until the pipe is bent to the desired angle. Actual degrees will be displayed during the bending process. When the angle is reached, the machine will automatically stop. To remove the tube, set the direction lever to R and press the trigger switch. The machine will first back out about 15 degrees and stop. It helps to wiggle the tube to break it free, then to remove the shoe pivot bolt and bending shoe to remove the tube. Press the trigger switch for a second time and hold to return to the 0 degree starting position. The machine is now ready to perform the next bending operation. If the tube material is low quality or its wall thickness is less than 1 millimeter, this could result in wrinkling or splitting. It is important in bending to be able to calculate the resulting length of the finished bend. These can all be calculated using the formulas and chart in the instruction manual. A is the applied size, the starting point of the bend measured from the end of the tube at the front to the 0 degree position on the former. L equals the total length of the tube before it's bent. L1 is the resulting leg length on the end which is bent, measured from the center line of the tube. L2 equals the resulting leg length of the other end of the tube, measured from the center line of the tube. LR is the reserved length correction, and that is the correction factor which must be subtracted from the intended leg length, L1, in order to know where to begin the bend, A. LM is the minimum length correction, which is the correction factor which must be added or subtracted from L1 and L2 to find out how long the straight tube needs to be at the beginning. Example: finding the starting position to get the desired leg length at 90 degrees, if you have a 1 1/4 inch tube and we want to make a 90 degree bend in the tube with a resulting leg length of 230 millimeters, where would we position the tube in the former? Since A equals L1 minus LR, we would take the desired leg length L1, which is 230 millimeters in this example, and subtract LR from the chart for a 1 1/4 inch tube at 90 degrees, which is 130 millimeters. Thus, for our starting position A, we would place the tube in the 0 degree position on the former, 100 millimeters from the end.